what are the assumptions we are making for doing stability or performing stability analysis of slopes. The stress system is assumed to be two-dimensional. So this is a very important assumption that we are going to actually this is the assumption we are making while you are performing stability analysis. That means, you see, the entire problem of slope stability analysis, we are trying to confine it to two-dimensional. You can see here, this is a picture. It just speaks about two-dimensional. Second assumption, what we are trying to make here. So it is assumed that Coulomb's theory is applicable for carrying slope stability analysis. It's good to discuss what is Coulomb's theory. S is a function of sigma. But strictly speaking, I many times we use it to say S is a function of sigma dash. So what is sigma? No need to surprise, sigma is total stress. Sigma dash is effective stress. I can write now sigma dash is equal to sigma minus U. You can ask me what is U? U is pore water pressure. This can be measured by using piezometers or by knowing the head of the water. We can be able to calculate U is equal to gamma of water into height of water. It is assumed that the seepage conditions and water levels are known, and the corresponding pore water pressure. Just now we discussed pore water pressure, gamma of water into height of water, can be estimated. It is possible to estimate the pore water pressure by knowing height of water. See, many times you see when you insert piezometer in ground, a small glass tube in ground, the advantage, you know, what is the purpose of piezometer? We all know it measures the water pressure. You can able to get the water pressure. So once you know the water level inside the ground, that means it speaks about position of groundwater table. So once you know the groundwater table, the position, you can able to tell, you can estimate the pore water pressure by using this formula gamma of water into height of water. So it is assumed that the seepage conditions and water levels are known and the corresponding pore water pressure can be estimated. So it's a general statement. So now the fourth one, plastic equilibrium. Plastic equilibrium are assumed to be satisfied so we believe that every particle is at the wedge of failure that we are trying to call plastic equilibrium. So the plastic equilibrium are estimated to be satisfied along the critical failure surface. Along the critical failure surface. So these are the main assumption. You can write etc. You can take additional assumptions also. But I will tell you one thing. So you can ask me, what is critical failure surface? It is very interesting word. In this slope stability analysis, we must have an idea about what is critical failure surface. Critical failure surface means failure surface a failure surface which gives least factor of safety.